Hello dear friends, welcome to another video of the Never Do Through the GUI what you can do through the CLI channel. I am Vangelis and today you are watching Web API benchmarking Node.js Express vs Rust actix-web. Yesterday I created a video again about the Web API benchmarking for Node.js and Laravel vs Rust actix-web. I will have a link up at the top of the video for you to check it out. But today, after a viewer requested this, but I also wanted to do it anyway, today I'm creating the same video for Node.js Express and Rust actix-web. We will benchmark these tools and we will compare the results. So let's get into the video. The endpoints that we will use are these, the 8081 port and 8082 port. Currently nothing is running, as you can see. We will start by the Node.js Express. Our Node version is the latest stable, as you can see, 16.13 at this point of the recording. So we will say Node server.js. We will start the server. So we have results here. Let's check a little bit the project. It's a typical Node.js Express project. We define this API that we are hitting, this route, and what we do is get the users from a separate function here. And we're getting 100 users with ID, age, first name, last name, and framework. And as you can see, indeed, it is working. So the next thing to do is to benchmark. We will use this terminal to benchmark. And the command that we will use is this one, which says that we will execute 100,000 requests and 1,020 of them are concurrent. This is not needed, I think, but anyways. So this is what our benchmark will do. But before we start it, let's also open up the resources panel for us to see what the effect is. Let's have it like this. Let me put it a little down for you to be able to see it all. I think we are good here and we are ready to start. Okay, I will start and I will bring it up again, no problem. So I'm starting benchmarking and we see also the the resources. We have some CPU usage here, as you can see. The memory is stable, which is good. Overall it seems quite good. Yeah, and we are finished. The resources return, yeah, the CPU usage. Okay, everything went well. We have a result. If you remember, PHP could not even perform this benchmark without stopping the recording application, but Node.js did perform well. Keep in mind that for this video, for today, we are running these servers on the host itself, not within Docker. Both of them will run on my machine. So we are ready to stop the server. We reload, we have no results, and let's go to the Rust API. So what we have to do is come here and say cargo run release. It's up and running. Let's check. Okay, we have our users again. Let's check the project structure quickly. The same here, we define a route here, which what we do in this route is we return this HTTP response, and this response is the getUser function, a different function which creates a vector with 100 users. So exactly the same setup. So we are ready to start benchmarking. Let's come here. Let's get the command from here. The command is the same, as you can see. We will use 100,000 requests and 1,020 of them are concurrent. So the last piece is to bring this here. And let's execute. Rust completed very quickly. You see these little spikes, no memory change, just these few spikes here. So we are ready to close this panel and start our comparison. So let's prepare the data here. Let me zoom in a little bit here. And I think we are ready to start comparing. The document path, okay. The document length, concurrency, it's the same. Time taken for tests, these are the numbers that matter. We are starting here to see them. Time taken for tests for the Node.js server is 18 seconds, 18.7. For the Rust server, 4.2 seconds. Complete requests 100,000, the same here. Failed request 0, which is quite impressive. Failed request 0.2. Request per second, this is the next interesting number. We are at 5,330 requests per second. And for the Rust, it is 23,595. So quite a difference here too. Time per request 191 milliseconds. Quite good compared to Laravel, quite good I would say. But compared to Rust, things are not so good because Rust needed only 43 milliseconds per request. And this is another time per request across all concurrent requests, 188 milliseconds. For Rust, 42 milliseconds. Okay, transfer rate, another number which is very important. We have 53,032 kilobytes per second. And for Rust, we have 237,060 kilobytes per second. Am I correct? 53,237,000. So quite a big difference here too. These metrics are, I suppose, about network connection. I cannot interpret them, I don't know. You have to check the documentation of Apache Bench. But as you can see, we have quite some differences here too. For example, look at this column. We have great differences. Anyway, let's go to this stat here. And we see the time in milliseconds for the requests, percentage of the requests served within a certain times in milliseconds. So 50% we have 184 milliseconds. Rust is at 4 milliseconds, which is a very big difference. And you see, generally we need very little time, most of the time, in Rust. I don't know exactly how these are interpreted, again, to tell you the truth, because 100% would mean that all the requests take this amount of time. So I'm not really sure how to interpret this, but again we have big differences here, as you can see, very big differences. So yeah, these are the numbers. The longest request for Node.js was 1.2 seconds, and for Rust 1.2 seconds, which is very impressive again, I have to admit. And I suppose Node.js performs so well because of the V8 engine, which is extremely fast indeed, and perhaps the async nature of Node.js also helps a lot. But overall, as you can see, our server is a lot more efficient and resilient to even DDoS attacks. When we use Rust, we have a very big difference in seconds needed to execute this test with the 100,000 requests. But if you checked my previous video about the PHP and Laravel, Node.js performs pretty well compared to that, because PHP and Laravel could not even complete the test with the recording application on, and in fact I had to pause it in order to be able to execute it. So kudos to Node.js, but of course Rust is the winner for one more time. So this is the video, this is the information I wanted to share with you. Hopefully it will be beneficial to you in order for you to, when you want to choose what technology you will use for your web services. And this is all I want to share, so thank you for watching and have a great day.